I always wanted to design a tachometer. It is fairly simple to build and the parts required are easily accessible. Here the parts are used: a 1306 OLED display, micro USB port and an Arduino Pro Mini. So let's understand the working of the system. At its heart, it has a rotor with a magnet attached to it on one side and an Hall effect sensor placed very close to it. Every time the magnet crosses the sensor, the Arduino makes a note of the timing and based on the interval between two crossings, it calculates the speed and sends it to the display. The system also has two more inputs, one for determining the unit of output, Hertz or RPM, and another for when to take the reading. In tachometers, we do not continuously take the reading, but only when a certain button is pressed. So this brings us to the rough design of the system. The body should have place for a micro USB hub, a display, the rotor and the Hall effect sensor, and its brains, the Arduino. The design was not as difficult to build as it was to reverse engineer the dimensions of the display and the USB hub. In particular, the holes of the display and the hub were so small that using a caliper was mandatory. I also did not want to use any battery inside the system. Instead, I wanted to make the tachometer power bank compatible. This 10,000 milliamp hour power bank can easily run the tachometer for over a year. This is the main body of the tachometer. It has two holes for the buttons and one oddly shaped large hole for the display. I also added holes for micro USB port and of course the rotor shaft. This is the casing of the rotor which will protect it and also act as a pivot for the rotor shaft. I also added some grooves so that it will later align properly with the body. This is the lid of the system which will protect its internal electronics. It also has some ribs so that the shaft of the rotor can take some axial loads. This little buddy right here is the one that will actually make contact with the rotating part. I will design the rotor later depending on the space that will remain inside. After a night of 3D printing, all my parts were ready and it was now time for assembly. This is the main body of the tachometer with grooves for the lid to slide in. I then tried to add buttons into the body, which I should admit was easier said than done. After a lot of efforts, however, I finally managed to get them in their place. The click really felt very nice. To fix them permanently, I used every hobbyist's favorite adhesive, super glue. I then took out a new Arduino Pro Mini clone and started telling the pins that we were going to use, which were digital pins 2 to 4, A4 and A5, and of course ground and VCC. As I did not want to permanently attach the display, I added female headers instead of soldering them directly to the display. Then tin and solder wires on teeny tiny 3144 Hall effect sensor. This small thing is the real hero of the project. After soldering everything together, it looked something like this. After making sure that everything fit correctly inside the body, I finally fixed the micro USB hub to the body once again. The two resistors are the ones which draw sufficient power so that the power bank does not shut itself down. After this, I decided to test the setup and it worked, except it was alternating between Hertz and RPM. I then took some measurements for the maximum possible length of the rotor. I thought a rotor with a 10 mm radius would work, but I completely ignored the thickness of the cover, which I added later. There, I had to trim some length of the rotor. I then took a nail, clamped it into the bench vise and cut its head off. I then opened Autodesk Fusion 360 for designing the rotor. Once it was 3D printed, I delicately added the magnet. The arms holding the magnet were very thin and I was afraid I will break them. Once it fit correctly, I added my favorite glue to fix everything. Once that was done, I tried to add rotor onto the shaft, but the hole was too small for the shaft to pass through. So I started twisting it on the nail. After some delicate and time consuming work, the tunnel was finally ready. It was now time for the assembly. I tried to push the tip of the nail into the cavity of the crosshead screw. Just when I thought the project was over, I could feel that something wasn't allowing the rotor to move freely. That was when I realized that the rotor was interfering with the cover of the system. I grabbed my wire cutters and then started trimming off the top and bottom of the rotor. I had to be cautious that I should not trim off too much or else the distance may rise to such an extent that the sensor may not even detect the magnet. Finally, I assembled the system one last time and I was happy to see that the rotor was spinning freely in the casing.